Let's solve example 412. I'm going to write down the givens first. Mass of iron is given 50 kilogram. Temperature of iron is given 80 degrees C. It is dropped into an insulated tank. It means that there is no heat involved. Q in or out is equal to 0. Volume of water is given 0.5 meter cubed. Temperature of water is given 25 degrees C. Determine the temperature when thermal equilibrium is reached. So I'm interested in T2, temperature in state 2. I'm going to write down the thermodynamics first law. Delta E system is equal to E in minus E out, and I'm going to consider the whole water, including iron, in the tank as my system. So, if I look at my system, there is going to be no heat involved. Q in or out is equal to 0 as given in the problem statement. There is no work done on or by the system, and there is no mass that gets in or gets out of the system. So right-hand side of the equation will be equal to 0. There is no energy gets in or out of the system. Left-hand side will be equal to delta E of iron plus delta E of water equal to right-hand side, which is equal to 0. So for iron solid, delta E is equal to delta U of iron plus delta kinetic energy plus delta potential energy. And I'm going to assume that there is no change in kinetic energy and there is no change in potential energy. So the system is stationary. So delta E iron is equal to delta U of iron plus delta E of water, which is equal to delta U of water is equal to 0. And for solid, delta U of iron is equal to mass of iron plus specific heat of iron plus T2 minus T1 of iron, which is given in the problem 80 degrees C, plus delta U of water, which is mass of water, times the specific heat of water, times the change in temperature. T2 minus T1 of water, which is given in the problem statement 25 degrees C, is equal to the right-hand side, which is equal to 0. Mass of iron is given in the problem statement 50 kilogram. Specific heat, I can just read it from table A3, and it is equal to 0.45 kilojoule per kilogram degree C. T2 is unknown. T1 for iron is given, plus mass of water. Mass of water is not given, but I know that mass is equal to density times volume of water. Density is 1,000 kilogram per meter cubed times volume of water is given in the problem 0.5 meter cubed, so mass is equal to 500 kilogram. Still water, I can read it from table A3, is 4.18 kilojoule per kilogram degree C. T2 is unknown, and the initial temperature of water is given 25 degrees C. So this is one equation, one unknown, can simply solve for the only unknown, which is T2, 5.6 degrees C. So when thermal equilibrium is established, both the water and iron will be at 25.6 degrees C.